So for the Tech Talk today, we are going to have Professor Dieu Tien Bui. Professor Bui is from the University of Southeastern Norway, and he's a very well-known uh, researcher in the area of GIS and AI for tackling environmental challenges. That would be also his topic of talk today. So I hand it over to you, Dieu. Dieu.
Yes. If I Hello everyone. Do you see my screen here?
Yes.
Yes.
Yeah. Yes. Thank you, Dr. Kwon and Laura, for organizing this talk today, and I'm very happy to be here to present something about application of GIS and AI in the last 10 years, focus on my research project for environmental modeling and prediction. Here we focus on the GIS, yes, because the AI is very popular in the world, especially in your field. But here is how to connect map, raster, vector, or something together in order to solve the environmental challenges what hot topic in the world in the last 10 years. A little bit about my background. I born in 3rd of December 1978. Currently, I'm full professor at University of Southeastern Norway. I work here from 2014 as an associate professor. I did PhD at the Norwegian University of Life Sciences, Norway, and then postdoc researcher one in 1 year in 2013 and 14. Originally, I'm from Vietnam, but I did PhD in Norway. I study bachelor and master at the Hanoi University of Mining and Geology. I worked 1 year in an IT company in Oakland IT Group IS in Oslo, working with GIS analysts, working mainly on how to have like a digital map for many channel, many company, many map system in Norway. I have some publication here and some book chapter. Also, I'm editor of Geomorphology, International Journal Digitals, and Journal of Modern Science. Also, I'm reviewer and working for a lot more than 30 international journal.
Yeah, just one thing, can you change it to the full presentation to the full screen mode?
Okay, I'm seeing F, yeah. How to click here, right? No, let me view PDF file, maybe easier.
Maybe.
Because that is automatic system from University of South in Norway, so it's automatic open like it. Yeah. Yeah. Okay, I have here. Yeah, a
I
little bit,
still
but
see the zoom.
I understand because I use multiple screen.
Okay.
Turn off. Yeah. I think here is easier to see, right?
Yep. Can you change to full screen mode?
Yes, presentation. Yeah, so a little bit some. PDF file.
We saw it in the PDF reader, and can you change that to the full
Yes.
screen mode?
Yes, that is okay. Everything are clear now?
Yeah.
Yes, yes. So for content of presentation today, firstly I would like to talk a little bit about the GIS because not all of you have some background in GIS, and then I focus on what I have done in the last 10 years. Focus on like GIS, AI, and machine learning to predict where landslide will occur in the future, and then we're going to predict predict when, where, and when, and then introduce a little bit about one of the most successful system about rainfall induced landslide early warning system using IoT sensor and something. The next one focus on spatial prediction of flood, of forest fire, of soil salinity mapping, and then for forecasting of deformation of hydropower dam. And lastly, I would like to introduce, I'm doing to establish a lab for AI and sustainability for my department in Norway. So I would like, for example, you can help us to contribute provide some suggestion or something, and how we can work together in order to get project funding from local and national in Norway and also in Europe, and we are open for that. So here of course, I don't. I have no ambition to present about definition of geographic information system science, but here I would like to say why we want, why we what and why we think about the GIS here, because GIS now is expand. It's very large. It's not like before map system, computer, hardware, and software, and something here. Because GIS now it can contribute to solving major societal challenges. Here I mean, okay, GIS is collection of map with different scale, different resolution, and different coordinate system, different time. Together, we can predict what happened in the future based on what happened in the past, because the location here, the position of the city, we know 1,000 years ago, or 500 years ago, and we want to know, okay, what happened in the future, because when we build a house, we build infrastructure, we expect to use that engineering in 20 year, 50 year, 100 year or more. So how we can do that? That is GIS can provide a very good like mean to predict them. And here I list GIS now catalyzes spatial knowledge about methodology. The difference between the AI and GIS application here is we focus on the position. It's spatial dimension here. So it including geography, cartography, for making map, recent map, remote sensing to collect data, geology and survey if we want to build, to make a plan for something with very high accuracy. And also combination with landscape architecture, landscape ecology, urban planning, computer science is from you, interesting for engineering and environment science and so on. We can build like a decision system, network, and science, and many things. So here we have data from what happened in the past and what we want in the future. So AI and GIS can connect together and to provide in different scenario. Okay, for example, if the road here, if it's the next 10 years, if they have flood or not, if they have flood, okay, which area will be affected, and okay, how many people staying in that, how infrastructure will be damaged, and then what we should do for this. Of course, its future is very difficult to predict, uh, but we can make some scenario and we can update it every year. So in this presentation, I focus on AI and GIS for real world problem. And of course, what we have that is data. Data is from is past, present, but we don't have data in the future, and we can use data in the past and present to predict in future. That is for landslide, that is for forest fire, for also flood and something. And usually, as you know, we have like a satellite data here available here, from like a very high accuracy, very high resolution, until to like a lower resolution. And like in Norway, we have data available for free, very high accuracy, from UAV, drone, from LiDAR, land survey data, from vector data, raster data, for everything. So problem here is how we can use artificial intelligence to predict, for example, catastrophe. Landslide still continue like in Norway. Flood is continue like last August is still big problem, and it's happen again and again. Very difficult to, we cannot prevent disaster from occurring, but we can predict, we can know what is will happen, and we can find some remedy measure. So the GIS data here, that is almost of the input data for the application of AI and GIS here. And we go a little bit for here in Norway. We have Norway digital here, like a Norge binder. It means we have all of the satellite data here, and area photo, drone photo for the past last 50 years until now, and it continue upload. So if we have project like Norway, we have data are available here for us. We have also data in Norway here, and one of the most difficulty in developing AI for predicting something for specific area is that we don't have enough data. The data is more important, and it takes much of time, and we can convert in a way AI and machine learning system can understand and can predict. And I introduce here because in for the project in future, so we can discuss a little more here and select area. And I hope data is everything are available, and what we focus on is only focus on developing of AI model. So problem here you see GIS data mining and AI in the last like more than 15 years. I focus on too much on application of machine learning model here for landslide modeling, forest fire modeling, and flash flood. In the last 5 years, I focus on deep learning, and I see the effective of them is much more different. And so here very popular for you. But here I make question: where is GIS? What is GIS? How we can use deep learning, machine learning here in GIS? How we can convert from real world problem via GIS map and connect it to machine learning, deep learning, and the other algorithms here. And in this presentation today, I will show you how I can connect GIS for machine learning, deep learning here for local scale, regional scale, and global scale also. And it's still like it's not. I mean that even though many modern methods have been proposed, but no one recognized or accepted is the best for own area in the world. So in fact, we have to test like sometime for my case, my project, I test until 100 algorithms in order to see, to compare, and to combine together. Because like even small 1% or 2% of accuracy will influence the mapping result. And here I would like to present about the project we have done, and most of them have been published in article from 1 to 7. So the first thing here, this paper have published in Landslide we predict where landslide will occur in future. For landslide study, as you see, it occur across in the world, but then we cannot. It's very difficult to stop landslide from occurring because climate change, the condition of the surface here, and rainfall problem here. So usually we study landslide, we focus on spatial prediction. We predict where landslide will occur in the future. And then we have to predict, okay, if we know this area have landslide in the future, but in future it is when? Future is mean tomorrow, is future is mean 10 years, next 10 years, next 100 years. If landslide here is next 1 million years old, if we can forget it. So we have to answer, okay, yes, when landslide will occur in future, we focus on temporal prediction. Okay, if landslide occur in the mountainous area, no people are living here, so how is risk? But if landslide is even small landslide occur in area with the road system, other infrastructure or people, like in Oslo in 2020, so that is big problem. So we focus on risk assessment, and then we can, for risk assessment, we can find remedy measure and focus on the resource to solve the problem here. And finally, we focus on vulnerability. If landslide occurs in this area with this magnitude, with affected area like this, how much money we have to pay for this? And in this presentation, I focus on only spatial prediction of landslide and temporal prediction of landslide. And I focus on like a topic maybe you are interested in is soft computing. Here in one of the biggest landslide area in north area of Vietnam, and you can see it's very big landslide occur something like this, and every year we focus on it because here is still hot topic in landslide now, like in the last year, more than 50 people die or something like it. So in order to predict where landslide will occur, we have to collect landslide inventory. Because we use data in the past is a key for the future. In other words, landslide occur in the past will be the same condition for the future. So in the past here is position of landslide, and we can check a lot of condition. Condition is mean geology, soil type, slope, aspect, curvature, land use, wetness index, and all of the factor we think influence landslide in the past. In the past, we should think to include it in for predict them in the future here. And here I can show like some picture of the like a shallow landslide, and here like a landslide here, and convert the here using raster here. And based on the input factor here, how many input factors? Some people think about 10 is enough. Some people think about like 20 is okay, something okay, or 5 or the different mode. They require different input factor. And with AI, we think that how many we include many factor in the model is better because we have many algorithms to check the contribution of them. And here I showed the map like the aspect, like you can see the relief amplitude, valley depth, topographic wetness index, stream power index, and something. And here you can see distance to geology boundary, and the data here are available because the depth in the one we have 30 meter available. But in order to have high accuracy, like in Norway, we want to have a 1 meter resolution. When we have input factor here and we have a landslide occur in the past, maybe last 20 years, maybe last year, and like in this area, we want to use landslide in the last 5 years because the change of the climate and the change of the surface here is most important in the last 5 years. And when we have input data and we can use like a modern here I use support vector machine, least square support vector machine, and we optimize the parameter like here, and we can use input factor GIS database here. We can update the database every year if something changed. If they don't change, like for regional scan or local scan here, so we can discard, and then we can build the model, and based on model here, we can build the output map. So in the output map here, we coding the landslide modeling here into binary or two class classification. It means in the area they will be classified in two classes. The first is landslide, the second is no landslide, and the output probability belong to the landslide class here will be used as the susceptibility index. And based on this, we build model here, and we assess the contribution of the factor to the landslide model here, and we check the accuracy of the model using Rocker here, and we transfer into the map like this, and we can see we can classify like very high, moderate, low, and very low. Yeah. So this map we provide where wind landslide occur in the future. It means the position, but don't provide about when. We don't know it's occur tomorrow or occur next month. And this is, of course, it still has value for like land use planning for the area. In order to predict when landslides occur in the future is much more difficult. Difficult here is not relating about the methods, but relating about the data use, the data we have. In the world now, only Hong Kong have very full data for this, but almost area in the world is quite difficult, even though in like in Norway. And here I summarize for you how I can do for temporal prediction of landslide for this area in this project for my PhD like more than 10 years ago. Focus on temporal prediction here. I used almost rainfall data in the last like 20 years in a different station. Yeah, one station, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and all of each of the graph here is from a station in for 20 year here. So you can see some day is rainfall is very high like this. Yeah, and here is the key and the signal to make a model for when landslide in the occur in the future. Based on the rainfall data here, I established a simple model here. I try to make a correlation between the daily rainfall and antecedent rainfall, because rainfall occur in this area for several days. Then the last day with very high rainfall, for example, over 100 millimeter. So landslide will occur here. But for the whole study area, 3 days, 5 days, 7 days, 10 days, 15 days, or 30 days should be selected. And I make the graph like this for daily rainfall. And finally, we see here where it have a clear the separation between the 15-day antecedent rainfall and daily rainfall over 100 millimeter here, and landslide will occur here. And based on the probability model here, we transfer into the rainfall on landslide here and 15-day antecedent rainfall here. And we have a equation like this. From the equation like this, we can compute where landslide occurs in future here. And I test here with 1, 2, 3, 4, 5 stations, and almost of the threshold here, when rainfall occurs over the threshold, so landslide occur immediately here. So this model here is like very effective and have proven high accuracy for study area like in this here. And based on this model here, we can transfer information here into a map because people want to see the map. And then I can combine like a spatial prediction we have before, and then we can combine with temporal prediction here. So with a landslide hazard equal the spatial prediction of landslide and temporal prediction of landslide here. And we can compute, okay, for this area for 1 year, what happened in future for 1 year, for 3 years, for 5 years, and so on. Because when you want to build a house or road system in this area, we want to know, okay, what happened in the next 1 year, what happened in the next 10 years, 50 years, and so on. So based on temporal prediction of landslide, we can combine with the spatial prediction of landslide, and we can provide two-dimensional information here. And based on two-dimension here, we can I convert it, I combine it into a landslide hazard map for in the scenario of 5 years. And which large area here, we can see red color, and for high, moderate, low, and very low. And we test with landslide after when we produce this map, and then we waiting what happened like it's next year, and we can see some landslide occur here. It fit very good with the prediction map here. So based on like least squares of a machine, or we can use other popular machine learning algorithm like decision tree, like logistic regression, like Bayesian regular network or neuron fuzzy. We can produce a lot of spatial prediction map here, combined with the temporal prediction map, and we can get the map here, and we can transfer here to the local authority to make some development. The next one here, some small area of landslide. We build already house, for example, here. We build house here, and we cannot remove the house due to the landslide here. So we propose a solution is we can use like a sensor to establish in this area, and we can make like a landslide early warning system for this. And this project here supported by Norway, like to Vietnam in the north, in the Hà Giang province. And like here is a bedrock area here, and just landslide something like this. Yeah, something like this here. And for rainfalls induced landslide early warning system here, we focus too much on about the technology because the modern we're using factor of safety here is very famous in geotechnic engineering. When the value here FOS here larger than 1 is mean indicator for landslide, and is stable when the value is less than 1. This method here is very expensive in order to collect the data for the landslide here. Based on like you can see like the coherence, the effective friction angle, unit weight, volumetric, hydrologic conductivity, and then something. Now we have to we have to drain the area here to collect the sample, and then we make it the lab, and then we establish the sensor and column here. And the paper public in this here, and you can click here later. So here we propose my PhD student before we propose the system like this. You can see like here's a landslide. S 1, 2, 3, 4, 5, 6 column node here. The sensor node we have soil moistures, accelerometer. We have port water pressure sensor here, and we have a wireless interface module here. It's a very popular in AI field, right? And we can connect with like PV solar panel. We have sync node. We have computer station we use GeoStudio simulation here already, and we connect web server, some mobile phone and website that is very, very popular now. But the key issue here is where to select the position for the sensor and how the depth of sensor here. And after establishing proposed model here, we can monitor the change of the of the landslide here. I will try about the 1 day, 5 day, 10 day, and 50 day. So we can see the factor of safety here, corresponding to the intensity of rainfall up to 20 millimeter per day, and the critical surface you can see it changes over different scenario. The value here is like a 1.2 is critical, lesser than 1, and 1.1 and something like this. So it's still landslide, but it's like very slow here. The detail because the time is quite limited, so I don't present it very detailed, like how to technique problem in how to use in detail. You can see like from the publication here. Yeah, I present it very detailed in this. The next one here is one of the big problem here is flood. Because flood we can classify into river flood, coastal flood, urban flood. Among that flood is one of the most dangerous, as you can see here. There are a lot of like material. The people die every year, like in Vietnam, in Asia. So how to predict flood is still challenge because it's occur in very short time. And rainfall occur like, for example, rainfall is in area far from this position around 100 kilometer or more, and then we suddenly we see flood. So I propose like a new approach in the world at that time. We still classify the area into classes. The first one is flood, and non-flood. So the key issue here is to make a position that occur the flood in the past, and that is a challenge because before we don't have like a drone, and we don't have like a satellite Sentinel-N like today, and it's time consuming, and if a large area is very big problem. But now is we can use like Sentinel-1 radar image for this, so we can work for the regional flood prediction. We use soft computing approach for this, and the picture here about flood and how to convert here into machine learning problem here you can see. The study area, this project is GIS by application for solving real-world problem here. We use data like before. Because landslide and flood is some correlation, so we see elevation, the slope aspect, curvature, stream density, different vegetation index, soil type, geologic information, and rainfall here. Like input data here. All of the data here we can collect it from like a satellite, or we can collect from the national database. And here is a study area. And here the paper has been published, and we can click here, you can see in the detail. But what is concept here? The concept here is we have to prepare flood indicator. It means what is the influencing factor? What factor influencing the flood in the past present? And we divide here study area in different layer, like elevation, a slope, curvature, like this. And then we prepare aspect, stream density. We organize the data here in GIS, ArcGIS Pro. and different vegetation index from satellite image. We prepare also the soil type based on national database here. We prepare also lithology. We prepare rainfall. That's the input factor here. Of course, rainfall here is like a different opinion about how to use rainfall for flood. And for our case, we based on the what is flood occur is last 5 years. The highest rainfall even that produce flood in the last 5 years is used to create this map. And based on this map here, we can build model here. And for flood here, I like only deep learning model. Why this? Because flood area is quite large, including a lot of pixel, number of pixel. And when I start to use deep learning model here, I don't know how is the best structure for this, and a lot of testing. And finally, I don't know why, but I see around 60 neuron here, 60 neuron, 1, 2, 3 hidden layer with input like this. Input here is the map, elevation slope, curvature, trim density, NDVI, soil type, lithology, rainfall here, input factor here. And I try to increase 128 here, but the performance of the model here is still not improved very much. So with this structure here I see is very good. And surprisingly, when I transfer the same structure here for forest fire, for groundwater modeling, and and for landslide, and I get the same performance. It's much better than compared to popular machine learning algorithms. And the output of the model here is non-flood class and flood class. But we don't use non-flood class values. We only flood probability value here to generate flood susceptibility index. And the result of the map here is very good result based on the data in the past. Because the project finished when we published paper, and so we don't have much more like funding to check flood in the following years. But with the data at hand, the result is very good, and we classify here is 5% of study area is very high susceptibility for flood here, and you can see like some flood something like this. And one of the most popular area in the border between Vietnam and China had problem with flood. So the same landslide here, we can predict flood prone area only. We don't provide information about when flood will occur in the future. That is still challenge, and that is the main limitation of this application here. One more research is about the forest fire, because like Vietnam, Indonesia, and like now you see in the United States, there are problem with the forest fire, and we try to propose an approach using GIS and machine learning to predict where forest fire will occur in the future, and in the six northern mountain area of Vietnam here. And the paper had been published in the Journal of Environmental Management. How we do that? We use also the data like the GIS data, like for elevation or slope aspect, for land use, related to roads, different vegetation index, rainfall, temperature, wind speed, and humidity here. In Vietnam, you see like some year we have a problem with El Nino, a problem with La Nina. With El Nino, we see the climate is very hot, or a lot of problem about like forest fire is continue like it. But some years La Nina, like very few, like for 2012, we have one or two, very few, even about the forest fire. So climate change index is very important in order to predict. And of course, we build like a training data set for data for modern and for data for prediction for checking modern here, and then we produce about the forest fire danger index. From the fire danger index here, we can generate forest fire susceptibility. The modern here we use multivariate adaptive regression discipline, and we optimize by the different flower pollination optimization. Why we use MASH? Because we test more than 50 to more than 60 model here, and this model provides highest accuracy and optimized by this, and we propose here. The method for making map here is based on the assumption that forest fire occur in the past is key in the future. So position of forest fire in the past, we know about it. We know clearly about it based on the database from the Vietnamese government. Then we collect the input data, and then we collect the condition of the climate index and vegetation index here, and then we put in the model, and then we can compute, and we can train compute model, something like it here. And then we can generate about a very high, moderate, low, and very low here. Yes, many researchers ask me about, okay, this map here is susceptibility. So it provide no information about like early warming system. I say yes because here easier for like land use planning or something. Another project I would like to introduce you here is GIS and machine learning for soil salinity mapping. It's based on almost of the satellite image. Here is project in the Mekong River Delta in Bến Tre province in the southern of Vietnam. As project here from the Vietnam Academy of Science and Technology. And you can see here our team to collect the soil sample in the fields, or soil sample in the field here. And the paper has been published in here. I put the link here. So the map here generated based on the Sentinel-1B SAR amplitude. In order to make the map here, we have to collect the position here of the soil sample. Yeah, you can see the soil sample here. Soil sample with different area. And the date of the, we have to plan, we have to make like, we have to see about how is a revisited circle of the Sentinel-1B. And then we see that, okay, the same day the satellite fly in this area, so we go to collect the sample. And we must collect, we must select the day with like no rainfall. Because if the rainfall in this area for that day, we will have problem with the satellite, the image here. The accuracy may be not good. Based on the sample here, and we have Sentinel data here, so we can apply a lot of calibration image here in order to get the input data for the model. We have only 33 soil sample salinity here because it's very expensive to collect the data of the big area. And we try different machine learning algorithms from Gaussian process, from support vector machine, random forest, multi-layered perceptron neural network, and radial function neural network. Yeah, because the sample is just 43, so we did not consider deep learning for for this project. And based on this here, we see like random forest provides a highest accuracy, and the output of the model here we transfer like into the map like this, and you can see here the soil salinity, the value from 0 to 19 for this area. This is very important for agriculture and for agriculture. And of course, when we have data like this, when we can make we can collect more data here to see how they can change over time.
Yeah, you have like 5 minutes more for your presentation.
Yeah. Finally, here for the deep learning, we're using for forecast thing of deformation of hydropower dam. Here, one of the biggest hydropower of dam in Southeast Asia. That is why being hydropower dam here, and it's up. That is one of the big problem, like in the forecasting deformation of hydropower dam here. How to build the model, and with this we collect the data from 1981 to 1990, and we apply a lot of algorithms in order to check if we can predict, provide high accuracy or not. So a time series of data we use like a dam depletion, upstream water level, downstream water level, air temperature, and horizontal displacement recorded. Based on the data here, we can see that we use deep learning with some parameter like this, and the result for training and validation here. Finally, we can compare the model together. You can see here. From sub-fork vector regression, Gaussian process, decision tree, neural network, random tree, and something. So here you can see with deep learning here, the accuracy result is exceptional. Measured by the training data set here, we use usually the most criteria is R square here, and R square here for validation data set. And in the last 5 years, I focused too much on the application of the machine learning and deep learning for real-world problem here, and I see that deep learning is like the key change, one of the key issues can help us to make a higher accuracy. And now the last part here, I'm planning to build a lab for AI and sustainability at the University of Southeastern Norway campus Bø here. And we have vision to establish Bø as a recognized hub for interdisciplinary research, innovation, real-world application in AI and sustainability. So I hope, for example, you and many researchers, they have vision together with us, and we can visit Norway, and we can together make some project in Norway and EU together. I put some mission here about how the impact of AI to build in Bø here. We focus on AI in GIS for about the IT software development, for engineering, entrepreneurship, and sustainable tourists, because that is the field we focus on in the Bø here. Currently, I have some new idea about like a flat in Norway using AI, and I'm continue discussing with our group here, with Dr. Kwon here and other researcher to build that. We have mission here. And then we have core activity. We got customized AI model development here and AI sustainability application. We provide some training, capacity building, and some research support and something. For partner here, currently we have like a Norwegian Artificial Intelligence Research Consortium in Norway. some university, Tampere University in Finland, University of Bolzano, Italia, in NTNU, Norway, in the Polytechnic of Montreal, and Ho Chi Minh City University of Technology here. So, of course, I have many like startup company around here, around us. They can contribute to our development here, and I hope, like here, you together with us to we can discuss. And if you are a researcher, you would like to work together with us, and we can organize other meeting and can yes go in more detail. Yes, because the time is quite short, so I hope to provide an overview for you about what I have done in the last 10 years in application of GIS and machine learning or for environmental modeling and prediction. All of the results here have been published and get a lot of citation. So, but in order to transfer the research results for the society, so it still need more research. Thank you very much.